All right, this lesson is going to give you a little bit of calculator help and remind you of a couple of functions on your calculator that can be really helpful when you're doing statistical things. So this talks about a forester who measured 27 trees in a woods. He found their average diameter to be 10.4 inches and their standard deviation to be 4.7 inches. So what I did is I put that on the normal curve down here. I put the mean on the 0 and then I went up 4.7 inches every time I moved one standard deviation to the right, and down 4.7 inches every time I moved one standard deviation to the left. The question is about what percent of the trees should be more than 18 inches in diameter. The problem is 18 inches, if this is 15.1 and this is 19.8, 18 inches is going to be about right there or so, which is not, doesn't happen to fall on an even or a whole number standard deviation. So when that happens, then to figure this out, we need to first of all get a z-score. And so just remember that in order to do z-score, what you do is you take the raw score minus the mean and divide by the standard deviation. Okay, so in this case, the z-score for an 18-inch tree would be 18 minus 10.4 divided by 4.7, and I get 1.62. Okay, what that means is that an 18-inch tree is about 1.62 standard deviations above the mean. Okay, but my question is not how many standard deviations it was. My question is what percent it is. So when you've got a standard or a z-score or a standard deviation score and you want to convert it to a percentile, then you're going to use your calculator. So now on your calculator, when you have a z-score to convert it to a percentile, you're going to use the normal CDF button, and I'll tell you how to get that into a minute here in a minute. And the normal CDF, you're going to put a lower limit and an upper limit. So what you're really wanting to do is you're wanting to see what percent is at 1.62 standard deviations above the mean, and it's more than that. So basically I want to know what percent falls in this part of the curve right here. I know that this spot is 1.62 standard deviations, and you just need to give your calculator a really big number for this limit. It's typical to put it in as positive 1,000. When you do normal CDF, you always put the left end of what's shaded and the right end of what's shaded in, comma the right end. So the left end, comma the right end. In this case, then I will put 1.62 comma 1,000 because that's the piece that's shaded on my curve. Okay, so I will go to my calculator. I'm going to just clear this out so it's not so messy here, and then I will go second, variables, and then I want normal CDF, which is number 2, and I will put in 1.62 comma and then 1,000 for that upper limit. Hit enter. Your calculator will spit out for you a decimal, which of course you can convert to a percent. So this is basically 5.26% lie above that. Okay, so 5.26% of the data fall in that part of the curve. Okay. Here's another one. What percent of the trees are between 9 and 12 inches? Well, if we go here, 9 inches is about right here somewhere, I'm kind of guessing. And 12 inches is about right here somewhere. Again, I'm kind of guessing. And I want to know what percent lies in between here and here. Okay? What I need to know, if I'm doing percent, I need to know normal CDF. But what I need is I need a z-score for that limit, and I need a z-score for that end of what's shaded. Okay? So I know that the raw scores are 9 and 12 inches. So I'm first of all going to get a z-score for 9 inches. So then I would do 9 minus the mean, divide by the standard deviation, and I get negative 0.30. So that means that it's negative 0.3 standard deviations below the mean. It's 0.3 standard deviations below the mean, which of course it is because it's to the left of the mean. And then I will do the z-score for 12 inches by doing 12 minus the mean, divide by the standard deviation. which is 0.34, which means it's 0.34 standard deviations above the mean. So the z-score for this is negative 0.3. The z-score for this is 0.334, and that's what you need. In order to do normal CDF, you always need to know z-scores. So now I will go normal CDF. The left limit of what's shaded is negative 0.3, and the right limit is 0.34. I will put that into my calculator, and I should get 25.1%, but I will check that here for you. So let's go to our calculators. Again, to get to normal CDF, you will do second variables, number 2. The left limit was negative 0.3, comma, which is right above the number 7, and then the right limit was 0.34. Close that, hit enter, and again I can move that decimal 2 places to the right to convert it to a percent. Alright, this time I am giving you the standard deviation, and you are going to go back and give me the raw score. Okay, so I am giving you the z-score. A tree is 1.7 standard deviations below the mean. So this is the z-score. Again, if you think about this little formula right here, z-score is the raw score minus the mean divided by the standard deviation. This 1.7 is the z-score. The piece that you're missing here is the raw score. How much did the tree actually measure? Okay, so you'll set up a little equation. Here we go. Be careful. This is 1.7 standard deviations below the mean. And when it's below the mean, that means the z-score is actually negative 1.7. If it was above the mean, you would leave it as positive 1.7. I don't know the raw score. Minus the mean, divide by the standard deviation. And of course, you'll solve this by multiplying both sides by 4.7 and then adding 10.4. And you should get about 2.41 inches. Okay? All right, then there's another function on your calculator that we have not talked about yet, and that is the inverse norm. An inverse norm can be used a couple of different ways. Inverse norm is a function you use if you know the percentile. So you will use normal CDF if you know the z-score or can get the z-score. And you'll use inverse norm if you know the percentile, and you want to convert that to either a z-score or a raw score. Okay? So we'll talk about this. The largest 8% of trees. So you have to be really careful about this. The largest 8%, think about that, the largest 8% is actually going to be over here somewhere, and the largest 8% is actually the 92nd percentile. Okay? Because the largest 8%, again, percentile scores are always how many are below that, how many are under it. So if it's the largest 8%, there's 92% of trees that are smaller, okay? So it's the 92nd percentile. And I want to figure out what the standard score is, okay? So what I'm going to do on my calculator is I'm just going to go inverse norm. I'm going to put the percentile in. If the only thing that I do is put the percentile in, my calculator will spit out a standard score for me. And that's what I'm going to do right here. Okay, so I'll go to my calculator and I will do second variables. I will go to inverse norm, which is number 3. I will put the percentile in. Again, inverse norm is what you use when you know the percentile score. You have to know the percentile first. Okay, hit enter. And then I get 1.41 about. Okay, so I get 1.41. What that means is this is a z-score, so it tells me that the largest 8% of trees are about 1.41 standard deviations above the mean. Okay. Then the question is, what is the minimum diameter of trees in the largest 8%? Again, the largest 8% is actually the 92nd percentile. Okay, so this is the 92nd percentile. And this time, I'm going to use inverse norm and put a few more details in there. I'm going to put the percentile in there. And then if I want to get it back to a raw score, if I know the mean and the standard deviation, I can put those in and my calculator will give me a raw score. So if the only thing I put in is a percentile, spit it out, it'll give me a standard score. But if I put the mean and a standard deviation in there, it will spit out a measurement for me, and it will be the raw score. So if I go to my calculator here, and again, I go second variables, inverse norm, I put the percentile in, comma, the mean, comma, the standard deviation, and go ahead and spit that out. I get about 17 inches. Okay, my tree is about 17 inches. Okay, and that should do it.